Hey, I think I am recording. We'll see if it works. We are in 7-4, geometric sequence and series. I am going to bypass all the mumbo jumbo and I'm going to give you some stuff over here. Write all this down. So use this little corner over here. I'm going to explain geometric sequence and series in the easiest terms that I can think. So, ready? Write this down. 1, 4, 7, 10, dot. Let's do 1, 3, 9, 27, 81, dot. Okay? They will ask you, is this series or this pattern of numbers geometric or no? Is it geometric or is it not geometric? Here is what it means to be geometric. Geometric is exponential. Which one of these sequences is an exponential sequence? The second one is when you are multiplying by the same number each time. You are taking this times 3 each time, yeah? Okay? So this would be an example of when you're doing like 3 to the x power, right? Okay? 3 to the 0 power is 1, 3 to the first power is 3, 3 to the second power is 9, etc. We'll get to the part where it's not starting at nice numbers. Just wait a second, okay? But this one is geometric. This is not geometric. Do you know what he is called? He is called arithmetic, okay? Because you are doing what each time? Here you are adding each time, and you've been adding 3 just because, right? Here you are multiplying by 3. So it is only geometric if you are multiplying by a number, the same number each time. Got it? Divide. That's a good question. Okay? All right, hold up. No. Just wait. She says, what if you're dividing? I'm going to show you an example. So let's say I have, hold on, be quiet. Shh. You gotta listen or I'm not gonna keep going. We'll do it the hard way then. Okay, Lauren had a really good question. Let's say you have a sequence that is 300 and then 100. No, that's not good. That's not good. Let's go. Let's go 400 and then 200 and then 100 and then 50 and then 25, etc., right? What are you doing there? You are dividing by 2. They will not write it as dividing by 2. They will say your R value, which is what you're multiplying by, you are multiplying by 1/2. So even if you're dividing, they will call it multiplying by a fraction. Do you see how that works? Okay, it's still geometric.
That is number 4.
Yes, it's still. Is that number 4 exactly? Yeah. Cool. There you go. Homework problem. All right. Okay. He is geometric. Yes. Because you're multiplying by 1/2.
So, is your answer just yes?
Yes, probably. I don't know. It depends on what they're asking. Sometimes they'll ask for the rate or the ratio is what they'll call it. They're asking for R. R is 1/2 in this case. What is R up here in this case?
3.
R was 3. It's what you're multiplying by, right? Got it? Okay? Geometric versus not geometric. Are we clear? Do we know what we're doing? What happens if these would alternate? Like, let's say this was negative, this was negative, this was negative. What would my R value be? He would be multiplying by negative 1/2 each time. Got it? Okay? All right. That was the easy part. Are you ready for the hard part? Okay.
We have to graph?
Oh, yeah.
It's a graph?
Graph?
What?
Okay.
Yeah.
Yeah, we'll get to that. Okay? All right. Let's talk about the two. These are the 2 harder things. I have like 2 more things to add and then we're done. Really, kind of. Okay? We have formulas. Here are some formulas. And I'm going to go with, like, let's say, I don't know. Let's do the function 2, 6, 18, 54, blah, 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 right?
Can we also graph this one?
No, yeah. You want to graph it? You want to practice graphing it? Sure. We can practice graphing it.
Geometric.
Okay, is this thing geometric?
Yes.
Yes. Geometric. Yes. What is R? 3. How do you graph it?
Oh no.
Don't know. Is it like
Here's
one-
how you graph it.
Is it 1, 2, 2, 6?
Yep, this is the point. Since this is the first number, this is the function 1, 2, 2, 6, 3, 18, 4, 54, etc.
To graph the first 6.
No, actually.
Okay, I have the first 4. What's my
So
next
you
number?
multiply 54 by 3.
5 would be
I don't know.
162.
Sure.
6 would be whatever that times 3 is. 6, 8, 1, 486.
This isn't
We actually
even
have to
bad.
graph it on the like.
Oh, this
on a
isn't
picture,
bad.
Just like draw a line.
You can draw like a rough sketch of it, kinda. So 1 would be at 2, 2 would be at 6, 18, like this. He's gonna do that, okay?
I can
Ish.
We can rough sketch.
Ish, okay? Now, please list out, if they don't give you all of the coordinates, please list out the first 6, okay? Got it? And tell me what the R value is. How about that, okay?
What if we just list them instead of graph them?
That's not allowed.
Why
I don't know.
It's like the same thing.
Just do a little,
Oh, so we don't
whatever.
actually need graph paper.
You don't have to be exact, because yours is not going to go up to all the numbers that you need to go up to. Okay, all right, ready for formulas? Here's the last thing to add is formulas, okay? There are 2 different formulas that you can write for the same pattern. The first one is called a recursive formula. This is the hard part, you need to listen. There's a recursive formula, and then there is something called an explicit formula, okay? The explicit formula is harder to write, but it's easier to plug numbers into, okay? The recursive has 2 parts to it, okay?
Is
What?
the explicit one with like the E looking thing?
No, that's the summation. We're not going to do that today. No, we're not doing those part. Yeah, there's another part to that, but we're not doing those. Okay, recursive. Here's what a recursive says. Are you guys all watching? There are ways that they have named some things, okay? They talk about something called an A sub n, or maybe they call it A sub n, okay? A sub n, this guy is the nth term of the sequence, okay? And what do I mean by nth term?
So
Any term.
Like the whatever term that you want. Maybe I want the 7th term. So the nth term would be A sub 7, right?
What about the
Okay?
first term?
The first term would be A sub 1. The 42nd term would be A sub 42, right? The nth term, it's just whatever my term is that I'm talking about, okay? To get to this sequence right here, we know that we are multiplying by 3. Got it? Are you ready? So what I do for the recursive formula is if I'm trying to find let's say the 7th term. Don't write this down yet. If I'm trying to find the 7th term in this sequence, I'm going to take 3, which is my pattern, and I'm going to multiply it by what?
20.
If I'm trying to find the 7th term, like the 7th term would be the next one, I'm going to take 3 times the 6th term, right? So A sub 6. Don't write this down. Don't write this down yet. Okay? Okay? If I'm trying to find the 7th term, I multiply 3 by the 6th term, right? If I'm trying to find the 21st term, I take 3 times the 20th term. If I'm trying to find the 142nd term, I'm going to take 3 times the 141st term. Got it? So here's how they write it. Because my pattern was times 3. Yes, yes. Okay? So I take 3 times that number just because my R value is 3 from the pattern up above. Okay? So the way that they write this is to find the nth term. I take 3, because that was my R, times the n minus 1 term. Do you understand what this is saying?
No.
A sub n is any term that I want to talk about. Maybe it's the 7th term. If this is the 7th term, I'm going to take the one right before it, which would be the 6th term, right? If I want to find the 12th term, this would be A sub 12 equals 3 times the 11th term, right? The one right before it. So A sub n minus 1 is just a fancy way of saying the one right before it, right? A sub n minus 1 just means the one right before it, right? So they just write it as this formula instead. That's the recursive formula. But we have to also, in a recursive formula, define what 1 is. What's the first term of the sequence?
3.
Go up above.
1.
Go up above.
1.
The first term of the sequence was 2. We have to say that because I don't know where to start from. I don't know where I'm starting, right? I could, like, I have to know what the first term is if I want to find the second term, according to this, right? And in order to find the third term, I have to know the second term, okay? Now, here's what the problem is, and this is where the recursive falls apart, okay?
Do you have to keep multiplying
What?
over and over?
Yeah, okay? Let's do another example right here for recursive. Let's say my pattern is, I don't know, 4, 8, 16, 32, 64, blah, 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 right? Okay, here's an example. You don't have to write this down, but watch, okay? 4, 8, 16, 32, 64. What is R?
2.
2. What's my first term?
4.
4. So if I'm going to write A sub n is going to equal
4 times
2 times A sub n minus 1. But I have to also say what the first term is. I have to have both of those in place. That's my recursive formula. So it says, here's the pattern. Here's what you do each time. But the first term is 4. Got it?
Okay.
You multiply by 2 every time, but your first term is 4. Done.
Got that.
Got it? Okay? That's the recursive formula. It's not so bad, but here's why it's bad. Ready? Let's say I had this pattern, and I want to know the 17th term.
You have to know this.
I have to know the 16th term. But I have to know the 15th term, and the 14th term, and the 13th term, and the whatever term. I have to know all of them.
But why
So there's no
So you
skipping.
have to know the 467th.
You would have to know every term before that. That's the bad part. That's why recursive is like, we don't like it.
Why
Okay?
can't you just do
It's a nice, easy pattern, but it's not very good, like with knowing the 72nd term,
Oh,
right?
So then there's that long,
Yeah.
long one.
So the other one is something called an explicit.
why
Oh,
can't
it's
you
like
just do 2 to the
Y.
17th?
It's like
What?
Why can't you just do 2 to the 17th?
y1 minus x2 equals y1.
That's the explicit formula. That's what we're going to do right now.
Isn't it like
Ah, look at that.
y1 minus
Okay. What?
x2 equals
You're close, kind of.
something.
Okay, are you ready? Okay, here we go. Here's how you do the explicit formula. It's not that hard, I guess. Okay, the explicit says if I want to know A sub n, okay, whatever the nth term is, okay, I have to know what my first term is. My first term is embedded into this formula. Then I multiply that by whatever my R is to the n minus 1 power. Now I don't have to write in what A sub 1 is. I already have it in my equation. Okay? So let's do this for, I don't know, this pattern up above here. Okay? A sub n is equal to, we had 3 comma, what did I go by? 3 comma 9. No, it was 2. I'm sorry, it was 2. 2 comma 6 comma 18 comma 54, this pattern, right? Okay?
Yes.
What was my A sub 1?
Your A sub 1 was
I am recording.
2,
Is 2. What's the R value? What am I multiplying by each time?
3.
3 to the n minus 1 power, right? So here's how we utilize this. This is my formula. That's my explicit formula. If I want to know, let's say the 4th term in the sequence, which should be 54, right? I am finding A sub 4, right? The 4th term in the sequence. I take 2 times 3 to the 4 minus 1 power, which is 3. 3 to the 3rd power is 27 times 2. Does that give me 54?
Oh my god.
Oh my gosh, okay? This is a really good formula to use when I want to know the 72nd term, because over here in the recursive, I have to know the 71st term, and the 70th term, and the 69th term, and the 68th term. Over here, I don't have to, because my A1 is already in the equation for me. Yeah?
Can you go over those steps again?
And this is an exponential function. What?
Can you go over those steps again?
Okay, yes. So over here, this was the recursive. So this is a different pattern, right? This is my different pattern. Do you see how we got the recursive? This is the recursive formula. Okay, we take A sub 1 equals the one right before it, which we call A sub n minus 1, times whatever the R value is, which in this case we are multiplying by 2. For the explicit function, we take A sub n is going to be equal to whatever your first number is times R to the n minus 1 power. So my nth term will be, what was A sub 1 for this guy? What's my first term? 4 times 2, because that's what I was multiplying by, to the n minus 1 power. Let's check our fifth term and make sure it's 64, right? If I plug 5 in right here, this would be 2 to the 4th power. Do you know what 2 to the 4th power is? 16 is 16 times 4, 64?
Yes.
You betcha, we did it right. So my explicit function, which I just wrote over, is a sub n equals 4 times 2 to the n minus 1 power. Okay? All right. Do I need to write those cleaner?
No.
No, we're good? Okay. Yes? Yes?
No, we're like, yeah,
Okay.
we're good.
Oh, yes, we're good? Okay. All right. Example 1, real quick. Geometric or not? Geometric. 2 to 6, 6 to 15.
Not.
If it's geometric, how do you get from 2 to 6?
It's geometric.
Times 3 is 6 times 3, 15? No, so not geometric.
What?
Yeah?
Oh yeah.
Okay? All right, this one. This is...
What's the difference in using the recursive and explicit? Like, if
Okay, what was the
run the
recursive
same
one
thing,
again?
why do we have to know both of them?
You
you
don't
not write it down?
Because the recursive is nicer because it's just like saying, hey, you take the one right before it, multiply by 2. That's it. But the recursive's not nice when it comes to like, what's the 12th term, right? Because then I have to know all the ones right before it. Okay? Example 2, what's the R value or what am I multiplying by? To go from -1 to -2 to -4, what are you multiplying by? 2. Okay? Find the first 6 terms. So there's 3. What's the next term? Negative 8. Okay? Negative. Okay, that's the 6 terms. There you go. We're done. Okay? That was example 2. Example 3, let's skip it because it's too many words. Okay? Let's practice this one and then we'll be done. Example 4. Okay? Do you guys want another example? Example 4. This is another one where we're writing equations. Yeah? Am I going too fast? The nth?
Power?
Is Emma in there?
Yes, she is.
She needs to leave now, please.
Okay. Shoot, she has to go. Okay, go to example 4 really quick. I know you guys are like all over on top of this. You're like awesome. Go to example 4. Let's do 2 more questions and then you'll maybe get a little bit better of an idea. So go to example 4, part A, just with me for just 5 more minutes. Okay?
You're awesome.
Okay, here's 2 things that we need. Go to this example. Everybody listen. Up here, please. Go to example 4, part A. This will help clear up some things. We'll do one more example and it'll just be one more under your belt. Here we go. Here's your function. What's your R value?
-3.
I'm multiplying by -3, right? -1 times -3, okay? Will give me 3. So R is -3. What's the first number? -1. So for recursive, here's your equation for recursive. A sub n equals your R value times A sub 1. Or A sub n minus 1, excuse me. And then A sub 1 equals whatever that is. Okay, so let's fill this in. Your nth term for this problem, I take -3 times the one right before it, which is A sub n minus 1. And A sub 1 is -1. Here is your recursive formula for that equation. This is just saying you take any term times -3 to get the next one. Any term times -3 to get the next one.
Rule, the only thing you really plug in is the rate.
Right.
Oh.
Yeah.
Could you do
Okay.
like a semicolon?
Sure. That's fine. That's fine. For explicit, here's your formula for explicit. A sub n is equal to R times, no, wrong. A sub 1 times R to the n minus 1 power. Okay? And we don't have to have that second piece. I don't have to tell you what A1 is because it's already there. So help me fill in this one. A sub n is equal to what? -1 times -3 to the n minus 1 power. There he is. Okay? Got it?
So it's pretty much one.
Do we need to see an example where they don't give you a sequence, where they just give you like this thing? What?
That's the 8th term.
That's the 8th term.
Oh, so you just have to like.
Okay.
So you have
So,
Do it again.
yeah.
Use the answer.
If the 8th term is 5, the 7th, 6th, 5, 4, 3, 2, 1.
Can you
I
scroll
don't
up
like
one second?
R is 5.
It's ugly.
Hold on. Kind of. No. To get from here to here, you're taking it times 1/2 every time. So how do I get from here back?
Oh.
Times 2.
So what's the 7th term?
Oh, you have to do it.
10. This is 20. This is 40. This is 80. This is, this is, okay, what's the first term? So A sub 1 is 640. Yeah? And R is 1/2. Okay? So for recursive, I've got A sub n equals 1/2 times the 1 right before it. And A sub 1 equals 640. That's my recursive. Okay? For explicit, A sub n is equal to A1 is 640 times R to the n minus 1. This is my explicit. Got it? See? So you're just writing the equations for those.
Oh.
So you never have to state the A1
You
for the
because A1 is embedded in there. Yes. And that's the really nice thing about this guy is because you can just plug in the 72nd number. Here I can't plug in the 72nd number unless I know the 71st number, right? Okay? So there is that. All right. That's all the further I'm going to go because you have enough information. I don't think you need any more. Was that okay? Okay. All right. Do the best you can. There is that. Okay? There you go. I'm going to quit recording.